So here I want to take a look at a few examples where we're adding and subtracting rational expressions that involve more than one variable. So the process is more or less the same though, right? We're looking for a common denominator if needed and then adding or subtracting the fractions once we have that. Okay, so in this first example I have 9x squared over 3x minus y squared over 3x minus y. All right, so the first thing I notice about this example is that it already has a common denominator, right? The denominators are 3x minus y and 3x minus y. So I can simply do the subtraction there. I'd have 9x squared minus y squared all over 3x minus y, okay? The other thing that I notice from there is that the 9x squared minus y squared, the numerator there, it's the difference of squares, right? So I'm going to factor that. 3x plus y times 3x minus y, yeah, all over 3x minus y. Okay, 3x minus y goes away, right? So sometimes that will happen when you're adding and subtracting. Always see if you can factor the numerator when you're done fully simplifying it, because if you can, there might be some additional things that will cancel there. So down in the corner here, I'm curious, that factor that I canceled out of 3x minus y, if I set that equal to 0, I guess we could say 3x can't be y. It's about the most we could say about that. So it's a little bit hard when there are multiple variables involved, but we could at least say that we know that to be true. Okay. Now, this next example of y over 3ty plus t over 2y squared, what is the LCD? Because we don't have a common denominator there, right? So I look at the numbers. I've got 3 and 2, so the least common multiple there is going to be 6, right? And then look at the variables. I have t and I have y and y squared. So t is included, and then between the y and the y squared, we pick the one that appears the most times, right? So it's going to be y squared. Okay, now that first fraction of y over 3ty, what do I have to multiply top and bottom there to get a common denominator? So it's missing, to get up to 6, I have to multiply by 2, right? It's got the t, but it needs an additional y. So I'm going to multiply top and bottom by 2y. Yeah. And then I'm adding to that this other fraction of t over 2y squared. Now, what's that denominator missing? Well, to get up to 6, I need to multiply by 3, right? And it's also missing the t. So I'm going to multiply this by 3t over 3t. Okay, so let's clean this up. We're going to have 2y squared plus 3t squared all over 6ty squared, right? Okay, so I would ask, hey, can I factor the numerator any? I can't. It looks like it should be able to factor with the squared terms, but you can't factor the sum of squares, and 2 and 3 aren't perfect squares, so we're done. There's nothing more that we can do to this. So one more example here. We're subtracting two fractions that have multiple variables. Okay, so for this problem I have 2 over rt minus 3 minus 2rt plus 3 divided by r squared t squared minus 9. Okay, so to get an LCD, I need to do a little factoring first, right? So I've got 2 over rt minus 3 minus 2rt plus 3 over, so when I see the r squared t squared minus 9, I see the difference of squares, right? rt is the square root of r squared t squared, and I'm going to have plus 3 times rt minus 3, right? 3 squared is 9. Okay, so what is the LCD? The LCD is going to be rt plus 3 times rt minus 3, right? Okay, because I have an rt minus 3 in both denominators, but it only appears once in each of them, right? So the first fraction, what is it missing in the denominator? RT plus 3, right? RT plus 3, I'm going to squeeze it in there, all right? And the other denominator is not missing anything, right? It's got the whole thing there, so we don't need to do anything to the second fraction. Okay, so in the numerator, I'm going to have 2RT plus 6 minus 2RT plus 3. Notice I'm putting parentheses around that to indicate we have to subtract the whole thing. All over RT plus 3 times RT minus 3. Right? So I'm going to have 2RT plus 6 minus 2RT minus 3 all over RT plus 3 times RT minus 3. Okay, so then 2RT cancels, right? 2RT minus 2RT. And 6 minus 3 is 3 all over RT plus 3 times RT minus 3. Okay, and there's nothing more to simplify in this case.